Hello, this video will demonstrate how to use the two-line LCD1602 display with the Raspberry Pi. Specifically, I will be looking at the model that has the I2C backpack attached. This is what it looks like. If you have the plain version of this display, then this tutorial is not for you. The plain version is not practical anyway. It would use a lot of GPIO pins and it has a complicated programming requirement. With this version, you need only 4 pins and the programming model is very simple. Other than the display, you will need some wires. This is what I will be using. The right-hand side matches the backpack pins, while the left-hand side will go to a breadboard. You also need a small Phillips screwdriver to adjust the contrast. The backpack module uses the I2C or I2C protocol to communicate with the Pi, which uses only 2 wires, SDA and SCL, data and clock. Please note that the display is a 5-volt device and it is powered by 5 volts. But due to design of the I2C protocol and the fact that the Raspberry Pi is a controlling device, it is safe to connect such display to the Pi directly. I suggest using wires of different colors to connect the display. This minimizes the risk of damage due to incorrect connections. For example, I'm using gray for ground, red for 5 volts, blue for SDA, and green for SCL. Here's the other side of the connection. I use the cobbler connector with the breadboard, but the display can be connected to the GPIO headers directly. You'll just need to use different wires. 5 volts and ground connections are close to each other here, while the SDA and SCL lines are connected on the opposite side. Before you start using that display with Python, you need to make sure that the I2C protocol is enabled on your Pi. You can use the Raspberry config utility to take care of that. This program is navigated using keyboard arrows, tab, and the enter key. Look for the I2C in the interfacing options and enable it. Enabling I2C requires a reboot. If you are connected remotely, you will get disconnected during the reboot. Once the system is back, you can check whether the I2C bus is active. I2C protocol supports multiple devices connected to the same bus, and it identifies each device by their hardware address. The I2C detect command can be used to see what is connected and what the addresses are. It's time to connect the display and see whether it is recognized. Double check your wires before making the connection. The display is backlit, and you can also adjust the contrast using a small Phillips screwdriver. Set it somewhere in the middle. Be careful not to short anything with the screwdriver while you make the adjustment. Looks like my display is ready to go. The 27 hexadecimal address happens to be the most common, but your display address may be different. For example, it could be 3F. This will depend on the chip version of the backpack module. As long as the I2C command shows the display is connected, you are good to go. The easiest way to program this display in Python is by using a dedicated library. There are many to choose from. I like things simple, so the library I recommend is RPi LCD. Here's the command to install it. This library has the default 27 address hard-coded. If your display has a different address, you will need to change it. You need to find the library on your system, and the following command should do that for you. This is the location on my system, and I could go there and edit the library if needed. You can use any text editor, for example Nano, but make sure to run it as root using sudo. This is the spot where the change needs to be made. Time to write a test program. With the RPi LCD library, the programming of the display is very easy. Just a couple of lines of code. You need an import and an LCD object instance. I will use two functions of this class, the text function to write to the display, and clear function to erase it. I'll use the clear function at the end of the program, otherwise the message will stay on the display after the program ends. The two numbers 1 and 2 at the end of the text function indicate which line of the display to use. This is an opportunity to adjust the contrast, especially if the display does not show anything, if you don't see the Hello Raspberry Pi message. The adjustment only affects the letters, not the backlight. The backlight in this model is not adjustable, it's always on, but you can turn it off by removing the jumper on the backpack. In one of my earlier videos, I have demonstrated an ultrasonic sensor which continuously printed distance measured to the terminal using a threaded loop. I think this display would make an interesting addition to that project. Let's do that. I need to import and initialize the library first. For now, I will just add the LCD display to the existing program loop. This works fine, but updating the display 10 times a second is an overkill. LCD displays are slow, and I would not write to them more than 4 times a second. This is also an opportunity to show you how to use two threads in a program. You may find that the LCD does not get always cleared when the program ends, despite using the clear method in the finally block. I think this has something to do with the RPi LCD library itself, the way it's written. I find that introducing a small delay after you stop the threads solves the issue most of the time. Now the display is updated only 4 times a second, independently from the distance sensor operation. That concludes this tutorial. I hope that you will have an opportunity to incorporate this display in your next project. If you like this video, please subscribe and I will make more. Thanks for watching.